Okay, we're going to start with the second example. I will record the first example at the end of this video. So if you're watching this video, we'll go back to that first example in a minute. We're going to start with the second example. We had some technological glitches in our classroom. Okay, you are planting 160 square feet garden with shrubs and perennial plants. Each shrub costs $42 and requires 16 square feet of space. Each perennial costs $6 and requires 8 square feet of space. You plan to spend a total of $270. So I notice that we have numbers involving money. We also have numbers involving the amount of space that things require. We have shrubs, so I'll make the shrubs be X, and the perennials, do you guys even know what a perennial is? Yeah. Perennials be Y. There's also numbers that are totals. So there's information for shrubs, there's information for perennials, and there's information about totals. So money first. The shrubs are $42 each, so 42 times X. The perennials are $6 each, 6 times Y. And the total amount of money is $270. Now space. The shrubs require 16 square feet of space. The perennials require 8 square feet of space. And then total, we have 160 square feet for our garden. So if you match up the money and the space, it should be easier to figure out those equations. And the order that you write the equations does not matter. If you have the 16x plus 8y equals 160 on top and the 42x on the bottom, that is totally fine. Okay, we aren't going to take the time to fully solve this. I just want you to think about how we would solve this. Substitution, probably not the best. We don't have a y or an x that's easily by itself. We probably need to do elimination. Should we try to tackle the x's or should we try to eliminate the y's? Definitely the y's. And you could take the time to figure out the least common multiple. Honestly, the easiest thing to do is try to get, multiply them by each other. So if your numbers are 6 and 8, you're going to multiply by 8 and 6. You're going to try to get 48. So I would multiply the top by 8 and the bottom by -6. Just make sure you multiply one of them by a negative, so you end up with 48y and -48y. Now, if you find a number smaller than that you want to multiply, great, go for it. But the easiest thing is just 6 and 8. 6 times 8 is 48. Make both of them 48. One of them 48, one of them -48. All right, do you feel like you could finish that one on your own if you needed to? Yes. Okay, let's go to the walnuts. This one is very, very similar, but there's one weird little quirk. So we're talking about walnuts and almonds. So I'm going to write down walnuts, almonds, and I do see a mixture total. There is a total in here. Walnuts cost, so some of the numbers are the cost or the money involved. And then I also see that they're talking about pounds. So pounds or amount. All right. Walnuts cost $3.50 per pound. So I'm going to do 3.50 per pound of walnuts. Almonds cost $2.50 per pound. So 250 times the number of pounds of almonds. And that's going to equal the total cost for however many pounds. This number right here is the problem. Because the other cost number I see is $3.25. Would it make sense for that to be $3.25? No. But they're saying $3.25 for 8 pounds of almonds and walnuts at $3.25 per pound. So we need to do 8 pounds times $3.25 per pound. What number is that? $26. So this mixture is going to cost a total of $26. We just had to find that number. So that's this 8 pounds times $3.25 per pound. Multiplying those together gave us our total cost for the mixture. Okay, the problem is now, what numbers do we have for this second row? I know that we have 8 pounds. How many pounds of walnuts do we have? Do we know? How many pounds of almonds do we have? We don't know. I've heard this referred to as like a naked equation. There's no numbers in front of the x and the y because x is really the number of pounds of walnuts and y is the number of pounds of almonds. So you just have x plus y equals 8. This one, you have a lot of options. You could solve this using substitution very easily. You could get the y or the x by itself and then substitute. You could also solve this by elimination. You could multiply the bottom equation by negative 3.5 or by negative 2.5 and solve this using elimination. So lots of options here for how to solve this one. Okay, let's look at the quarters and nickels problem. This is another naked equation problem. Samantha has 43 quarters and nickels in her wallet. Okay, number one, her wallet's heavy, and seriously, there's no pennies in there? Seriously? That many quarters and nickels and no pennies? That's nuts. All right, she has 43 quarters and nickels in her wallet. If her change is worth $7.75, how many of each kind of coin does she have? First of all, let's do the naked equation. Number of quarters plus number of nickels is going to equal 43 coins. The other equation is going to equal the total cost of $7.75. I guess I don't really need that dollar sign in there, do I? How much is a quarter worth? 25 cents times the number of quarters will tell us how much money we have from the quarters. 5 cents times the number of nickels we have will tell us how much money we have in nickels. Add those together and it's the total of $7.75. Again, this one you have lots of options for solving. You could solve by substitution, you could solve by elimination, whichever you preferred. Give me a thumbs up if you feel like you could solve this equation on your own if you had to. Okay, pardon the extra noise. Here is the first example from our notes today. I already highlighted there's 2 types of information in this problem. There's people information and there's money information. What we ultimately want to find is how many pans of pasta and how many sandwich trays. So that's going to be our x and our y. So we're going to set up a table with x, that's our pasta, and y, that's our sandwich trays. There's also totals in here. The 2 types of information are the number of people and money. So I've got this table that I'm going to fill out, and this table is going to help me come up with my system of equations. So people pasta. People pasta is 14. People sandwiches is 6. And the total number of people is 64. Money pasta is 39. Money sandwich is 12. And the total money is 150. Now, how do you take this and create equations? 14 people times the number of pans of pasta. That will give you how many people are fed by pasta. 6 people per sandwich tray times the number of sandwich trays. That gives you how many people are fed by sandwich trays. Add those together and you get the total number of people that are fed. $39 times the number of pasta, pans of pasta. That's how much money we spend on pasta. $12 times the number of sandwich trays. That's how much we spend on sandwich trays. Add those together, and it gives us the total amount of money that we spend. Sorry, looks like my battery is running low. I don't know if that showed up on the video or not. There we go. That gives us our two equations, our system of equations. To solve these, substitution probably wouldn't work very well. I would use elimination, and this one's actually kind of nice because we have this 6 and 12. So I would multiply the entire top by -2. That would give me -28x plus a -12y equals -128. My original bottom equation, 39x plus 12y equals 150. Add those together. Divide by 11. We end up with x equals 2. Then we go back to one of our original equations. I'm going to pick the top equation. 14 times 2 plus 6y equals 64.
This is not hard. It's tedious. At least the way
And then we subtract 28. We divide by 6, and we get y equals 6. So this means 2 pans of pasta and 6 sandwich trays. That is our final answer to that problem.